So in our previous video, we've already completed the data preparation bit. In this video, we'll apply k-means clustering. We can call the k-means from sklearn cluster module. K-means, as you know, would require us to pass a number of clusters to begin with. These are the cluster seeds that we typically start with. What is this random state doing here? This random state could be any numerical value that you can pass here. It is put here just to ensure that we get consistent results. Since the cluster seeds in case of k-means clustering are initialized randomly, you may end up getting different results every time you refresh your code. This random seed only ensures repeatability and reproducibility, which means if someone else gets your code, this person would get the same outcome as you got when you ran with this particular random state. So don't ever try to optimize your code based on this. There's nothing here to optimize. Just put a random number here. And we are choosing 3 cluster seeds to begin with. We'll see to it if we need to change this number later. The syntax is pretty simple. You have passed the number of clusters in random state, and in the next step, you are fitting and predicting together using fit predict on what? On the treated data that we have prepared so far. Let's just run this. So this would have generated 3 cluster labels starting from 0, 0, 1, and 2. So what we're doing is we want to store these labels to our copied data frame and to the original data frame as well. Let's just run this. I can show you the head of the copied data frame. You can see the last column is the cluster label, 0, 1, and 2. This is how these values are. Let's scroll down. I can show you the original data frame. Of course, end of the day, when you want to convey something, you have to convey it against the college ID. The specific feedback needs to go to the college, right? So we are including the college ID in the original data frame as it was. And it again has the original variance of the airport proximity and median salary. Here are the cluster labels. If you want to check the size of the clusters, how big are these clusters? We had 100 colleges to begin with. How many values fall under each of these clusters? How many colleges fall under each of these clusters? We can do that by doing value counts on the k-means label. So we can see cluster 0 has 44 colleges, cluster 1 has 34 colleges, and cluster 2 has 22 colleges. Now this 0, 1, and 2 should not be interpreted in an order. It's just a label assignment. There's no order in these clusters. There's nothing like 2 is better compared to 0 or so. Just look at these as the labels assigned. Once the cluster labels have been added, the next step is always to interpret the clusters. What are their properties? How these clusters are different? On what basis we are saying that something needs to go to cluster 0 versus something needs to go to cluster 1 and something needs to go to cluster 2. So this is something that we will do on the original data. So in this particular view, we are dropping the college ID because while aggregating the data, college ID is not significant. We don't want an average of the college ID or median of the college ID, but the college ID stays with the original data, and we can see based on the college ID what the cluster label is. Right now, we are interested in interpreting the clusters, so we are just temporarily removing the college ID from this view, and we are grouping by the k-means labels and looking at the median of all the variables. So let's just run this and see what is the output. In fact, we can also look at mean of these variables if we don't have outliers in our data. But there was just one column where we had some outliers, so I chose to go with a median here. Let's interpret these. So we have these 3 cluster labels, and these are the median ratings that we have on all these aspects. And the original variables, unscaled versions of these variables will be interpreted as is. So let's understand how these clusters are different. Would you agree that cluster 1 is consistently performing below cluster 0 and cluster 2 across all the ratings or most of the ratings? Teaching-wise, it's the lowest. Infrastructure-wise, it's the lowest. Research opportunities-wise, it's the lowest. Industry interaction-wise, it's the lowest. Placement-wise, it's the lowest. Location, diversity, everywhere, this seems to be the lowest rated, even on extracurricular activities. In terms of distance, it is somewhere in between, but you can't really do much about an institute's distance from the airport. Neither you can ship the institute very often, nor you can ship the airport. So it may not matter much. Yeah, even after this institute is overall rated low, it seemed to have got a better median salary compared to the cluster label 2, which is very surprising. So it could be because there could be some brilliant students in these institutes as well who got very good placement. They prepared so hard that they stood out from the rest of the crowd. This is the median value. So that's very interesting here. However, let's look at the cluster 0 and cluster 2. They seem to have more similarities. But if you closely look at this, you would realize that cluster 2 is doing better on a number of aspects. For example, cluster 2 is doing better on research opportunities, on industry interaction, placements, location, diversity, financial aid, extracurricular activities. It's closer to the airport, but it is not doing that great on the median salary. So the placements are good. Generally, people are confident that they get placed here, and that's why they're rating it high. But the median salary itself is not that high. Okay. Whereas cluster 0, if we look at, is doing better on the teaching, which means the faculty quality is better here, and infrastructure. These are the two critical aspects, teaching and infrastructure, which are better in case of cluster 0. And in fact, their median salary is the highest of the all. So each cluster has its own properties, and that's why they have been segregated like this. The next question that arises is, how do we know that we should have had 3 clusters? We know that k-means starts with the number of clusters decided, but is there a way that we can determine the right number of clusters? That will follow in our next video, where we'll cover a little bit of theory regarding the within sum of squares, a way to determine the right number of clusters, and also something that's known as the Silhouette score. And then we'll do this hands-on.